So we are now on example 2 of law of cosines, where we are given the side of a triangle. So first things first, we're going to sketch a triangle based off of the given information. And again, you can just draw a random triangle. I'm trying to be a little bit more exact because I know the answers, but if you just drew a random triangle, that's fine, not drawn to scale. We're given little c is 4, little b is 6, and little a is 9. The note that I'd like you to record here is that you're going to find the angle opposite the largest side first, using law of cosines. Okay, one thing to note is that most students, just like the previous example, will do law of cosines first, and once they secure the angle measure, they'll move on to using law of sines. So the tricky part about this is if I choose to use law of cosines to find angle A and then angle B and then subtract the 2 from 180 to get the third angle, then I don't have to worry about this note. But if you decide that you want to use law of sines after the initial law of cosines, then you want to keep in mind that you have to find but it's highly suggested that you find the angle opposite the largest side first. And the reasoning for that is the law of cosines is going to, if you think about cosine, when you have cosine, it's positive in the first quadrant and negative in the second quadrant, which means that in obtuse angle measure, if we're trying to find cosine of an angle measure, does exist. However, with inverse sine on a calculator, they're only going to provide answers that are acute values because of the restriction on the range of sine. So we want to make sure that when we're doing law of cosines followed by law of sines, and we're given a side situation, that we find the angle opposite the largest in the event that the triangle ends up being obtuse. So in this problem, that angle measure that we're going to find is angle A. So when we start the problem, we are going to write, if I want angle A, then it's going to be a squared plus b squared plus c squared. So it's like Pythagorean theorem. And then the next part is minus 2bc. And then the end would be angle A, which matches the beginning a squared. And so when I plug everything in, I should just be missing one piece of information, which is the angle. So as you solve this more frequently, I'm going to have you practice isolating without a calculator so that if you were to write it in calculator ready form, you'd have it so that cosine of A is isolated. So how do we go about isolating? You would undo the addition first, so subtract 6 squared, subtract 4 squared, divide it by, so actually let's write that as a step here. So notice that I'm leaving all of the hard work for the calculator to do. All I'm doing is subtracting 6 squared, subtracting 4 squared, and from there on the right hand side, I noticed that there's 3 factors in front of cosine of A that I want to get rid of. They're being all multiplied, so I can divide through by those factors, -2, 6, and 4. And so now this is just one giant expression that I have on the left, and then on the right I have cosine of A. So the question is, how do you undo cosine of A? You take the inverse of both sides. So I'm going to say that this is the expression that is in the parentheses. And when you are solving for, so I'll just put answer here. So when we're solving for angle A, we're going to say angle A is equal to the inverse cosine of the answer above. So 9 squared minus 6 squared minus 4 squared all over -2 times 6 times 4. Now, your calculator does not do PEMDAS automatically. So we may see it like this. If you don't have a graphing calculator that automatically separates the fraction, what I'd highly encourage you to do is stick in these extra parentheses here so that your calculator knows that's the numerator and this is the denominator. So inverse cosine of that expression, and that's very important because otherwise you might get a different answer if your calculator is not interpreting order of operations correctly. So angle A should be 127, and it is obtuse. So we found the obtuse angle. Now we can use law of sines because we found the obtuse angle already. The other angles must be acute. So then you can pick whatever angle to solve for next. So we're going to use law of sines to find angle B. So sine of angle B over 6 is equal to sine of 127.2 over 9. We're using the information that we found, which is angle A is 127.2. The side across it is 9. And then we solve for angle B by isolating it. So that's going to be the inverse sine of 6 times sine of 127.2 over 9. And finding the inverse of that on your calculator, again, try to write that expression in your calculator with parentheses around the numerator. Angle B should be equal to 32.1. And so now that we know angle A and angle B, we can find angle C by finding the sum of the two previous angles and subtracting it from 180. And we get the measure of angle C is equal to 20.7. So to highlight all our answers, law of cosines we found by using angle A we found by using law of cosines, angle B, law of sines, and then angle C, the difference between the